Okay. It should be able to read my mind while it's at it. Okay, now, if you sketch the graph that I told you to sketch, or I didn't tell you to sketch, I recommended it, okay? You see that if you follow this curve here down to here, and then again, from here up to here, you have this and this, right? And that's on which function? That's the squaring function. Okay, there it is. Now, if you didn't see that, it might not have occurred to you to look at it that way. But if it's not obvious to you from the shapes of these functions and the details of the construction, which you have to have perfect, okay? And most of you do. And those who made the construction, a lot of people didn't make the construction, wasn't required. If you have the construction, you can identify this segment and this segment as parts of the squaring graph. Okay? So there it is. Now, if you match up coordinates, if you have the table for the squaring graph, you got the point -2, 4 and -1, 1. Only the squaring graph has those 2 points. Okay? And it's the only point that has -1, 1 out of the 3. There are other functions that go through those points, not the 3 that we're looking at. Okay, so let's get some transit column here. And now what about this? Well, it's going up. It's not on the squaring graph, because this point certainly isn't on the graph of the squaring function, even though this one is. Okay. That'd be the point -1, 1/2. Well, that's on the graph of the exponential function. Okay. And you can see it right here. Now, it looks a little straighter there than it does up there. I kind of exaggerated the curvature. Just to make sure you didn't see it as a straight line, okay? But it looks fairly straight between there and there. It doesn't, starts getting more curvature. Okay, well, but there it is. So we can see first three intervals, this graph, right there. Okay, now what's left? This thing. Well, you've got the reciprocal function. And looks like I never follow each other. Okay, there it is. So I'll just trace it out here. This. That's SQFN for squaring. And this one also. Now, if you wrote x squared or y equals x squared, that's fine too. Okay. I'd like to use the names. Kind of a useful thing to be able to do. And then here, it's all the same shading. Exponential function, which is 2 to the x. And right here is the reciprocal function. I'm not using much yellow. Ready. It's 1 over x. So now, if this function is y equals f of x, it's a squaring function of what domain? No domains from -2 to -1, right? On the domain, now it's closed at this end because it's a closed dot. It's open at this end. So I'll make sure. Now I didn't leave myself room to write the whole domain, but also the domain 0, 1. Now I don't know whether to put an open dot or a closed dot on this. Okay, so it kind of becomes a choice. You'll see why in a minute. So I haven't completed that notation. X, f of X function on the domain, but I'm just gonna write the word on. -1, 0, and that's closed. Because we have, yeah, I got a closed dot there and a closed dot there. Since I said that was closed, I'm gonna say this one's open. And we're gonna change it. And if you're doing this, you're gonna do that, I expect you to identify the fact, well, that's not a function. It's got two different values when X equals 0, right? Violates the condition of a function. And a lot of you, when you're doing these piecewise functions, drew graphs that violated the heck out of function, have three values for some of your X values, okay? Read your notes, okay? You know, graphs look like this. And well, X is here, and which value is it? Which value is the Y? You can only have one Y, right? So if your graph looks like this, it's dead in the water. Okay. No offense. Fix it. Now, then it's the reciprocal function. On 1, 2. Now, we need a parenthesis or a bracket here, parenthesis or a bracket here, right? It can't be both places because then you wouldn't have a function. Then you'd have two different values. And since the two functions meet there, I wasn't able to indicate whether it's open or closed. But what I did was kind of an open circle over a closed circle, but it's still not clear which one is which, right? So you get to choose. So what I expect you to do is make one of these open and one of these closed. So we're going to make a choice. Everybody vote. Put your thumb like this. And I want to see thumbs ready to vote. And flip your thumb up if you want the open bracket here. Okay, let's count. 1, 2, 3, 4, 5, 6. Okay, then. Took the easy choice, but that's fine. It's an arbitrary choice. I don't care which one you take. Okay. But if this is open, then this is closed. Okay. Now, does all that make sense? Okay, now things that you need are in order to see this is the ability to make accurate graphs of the three functions. I told you each function is represented at least once. There are 4 segments, so one of the functions has to be represented twice. Okay. And that happened here and here. That just once and once. And right there are the two intervals. And right there is a single interval for each of the other ones. Okay. Now, how do we write this in mathematical standard mathematical notation? We say that f of x equals x squared from -2 to 1, including -2, but not -1. 2 to the x. One to 0. X squared again. And then 1 over x. Okay. Now I recommend that everybody take another look at this assignment on the graphs of what's called piecewise functions. I didn't talk about that before. Okay. I want to see what you do with it. And some people did quite well with it, but most people, they at least one serious mistake. Okay. All partly because you might not have understood the notation from what you were told. You should understand it now in terms of this example. And you should understand how to look at some of these graphs. So you go back and see, well, there's the obvious answer. Go to the half credit page, so you know it'll tell you whether your answer is right or wrong. Okay. You go to the real page and go through practice, but it's not going to tell you necessarily whether you're right or wrong. I'm not sure how that works. Okay. If it tells you whether you're right or wrong, great. Use that. Make sense? Now, the other thing is, I'm not sure exactly what the algorithm is for grading it in open math. So I kind of regraded. If you get almost everything right, it gives you 0. I'm going to give you at least 10 credit. Okay. Depending on how serious your mistake is. If you miss 1 less than or equal, as opposed to less than, I'm probably going to give you 3 credit grade 10s. Okay. Because I want the grading to reflect what you know. And if you're trying to grade it automatically instead of an algorithm to do it automatically, it gets to be a real pain if you have too many conditions on how many points you get for this, that, and the other. Okay. So the people that wrote these problems are doing it voluntarily. I'm going to throw stones at them for making the grading a little simpler than I would like to see it. I'd probably do the same thing. Okay. All right. Okay, that's and the domain and range. Okay. I didn't ask for the range. It's a range about. I'll indicate that. That piece of green chalk, right? It's not a pleasure piece, something. Well, every value, every y value from here to here occurs because any horizontal line you draw is going to go through at least one of these graphs, right? Not a one-to-one function because the points here, between here and here, that have 2 x values for a given y value. Okay. A one-to-one function has just one y value, or one x value for every y value. Now you got to have exactly one y value for every x value. That's a function. Think about what one-to-one means because that terminology is going to be important too. And you've seen it already, so kind of lock it in. Okay. And there's your domain. The range is the closed interval 0, 4. And doggone it. You know, when I wrote this out, I got to stop working on that side of the page. Just to be as clear as possible. I said, f(x) is a square function of the domain -2, 1, union 0, 1, there and there. I think that's pretty obvious. It should have been on the screen. Okay. So just in case everybody needs it, this is the exponential function where, well, there's your exponential function. It's closed here, it's open here. So it's from -1 to 0, not including 0. And the reciprocal function, 1 to 2, right there it is. And it's closed here and here. It's closed here and here because we chose to make the, sorry, reciprocal function from here to here. We chose to make the squaring function open at this end because it was ambiguous. And then we had to make the other function closed. So, yeah, that would be this way. So the reciprocal function between 1 and 2. Then we write it this way: x squared here, -2 to 1, not 1. 2 to the x from 1 to -1 to 0, including 1 but not 0. X squared from 0 to 1, including 0, not including 1. And then 1 over x from x equals 1 to 2, including both 1 and 2. And I do apologize, you know, watch all that without being able to see what it is. Okay, that's the range in the domain. Well, the domain includes all numbers from -2 to 2 because everything from -2 to 1, not including 1, but now you include 1, right? And then you get to go up to 0. You don't get to include 0 here, but it's included here. And then everything from 0 to 1, not including 1, but it's included here. And then you go all the way up to 2 and include 2. So the domain -2, 2. There were a couple of cases where people didn't write the domain on one of the problems in interval notation. They wrote it as an inequality. Problem didn't say express it as an interval. Okay. So what you wrote was perfectly okay, and I gave you credit for it. Okay. You can check that out. I think I made a note when I did that, but in any case, if you wrote the correct domain when it didn't tell you to do it as an interval, I gave you credit. Even if it told you to do the interval, I'd probably give you half credit for doing the right inequality. Okay. All right. Well, I have a lot of things to talk about. So maybe we'll have. Now, that was your domain and range. I hardly read these things. They write black on dark red. You know, who in their right mind writes black on dark red if you're trying to make it readable? Somebody with questionable eyes. Okay. So we got rates of change and composite functions. It's two big deals. I don't see a good way to rearrange the assignments without bunching them up too much. But we'll see how we do. Okay. Let me look again. Make sure I'm saying the right words because I kind of see them all as one. So, okay, rate of change. I abbreviate that ROC. Can't read that. You see that? Something looks like that. I'm saying rate of change. Okay. ROC with a bar over it. Is delta Y over delta X. Okay. Delta Y is the change in Y. Delta X is the change in X. some, I should say, specified interval of the domain. So the interval 1/2, 2. Now there's a term that I didn't use, this bare bones idea. The rate of change of y with respect to x. And I want to see that with respect to when you write things out. Okay? There's a good reason for that. It's because in calculus, that with respect to becomes very, very important. And this is a pre-calculus course. Okay? For most of this course, it's going to be obvious with respect to what. And open math isn't going to usually use with respect to. Okay? You want to get used to it. You will be glad when you get to calculus that you got used to. You might not be glad because something is going to seem obvious to you that's not obvious to everybody else. Okay? And you'll be happy that it's obvious to you. You think you're smarter than they are, and maybe you probably are. Don't let it go to your head because you saw it here first. Okay? Let it give you confidence. It's going to be important. So I want to see with respect to. And it's changing this with respect to this, okay? Change to the numerator with respect to the denominator. It isn't stated quite rigorously. I think you can do it, okay? If I did a rigorous statement, it'd get too wordy and you would understand. All right. So what's the rate of change of y with respect to x? Okay. Look at the definition. And what do I mean by delta y? Delta y is the change in y. Delta x stands for the change in x. Ideally, you would have seen that notation and read it as change in, but I think maybe not everybody has something to measure. Okay. So see if you can process this question and write out an answer in the next 2 minutes. Can't spend any more time on that, but I want to see if you, to what extent you're getting this. Okay, a side comment. This is not a point. I saw this as a point on the graph. People had a graph with a point 1/2, 2. Adding a point has parentheses. And sometimes an interval has parentheses too. It's got a bracket in it though. It's almost certainly an interval, and I even said interval. It didn't say point. If I said point and wrote this, I'd be violating standard notation, right? Got to be very careful about notation, and you should be used to the idea from open math. You use brackets and parentheses and points. You get stuff marked wrong if you do. Okay. Again, though, sometimes you use parentheses and intervals, and that can be confusing. So get that straight. Don't make that mistake. Now, I would think that from everything we've done, you could kind of quickly you can do this. How long does it take me? Okay, kind of a sloppy graph, but that took me less than 30 seconds. Okay. no reason you can't do a sloppy graph in 30 seconds. If you can't bring yourself to do a sloppy graph, well, try to learn to do things sloppily when you're in a hurry. Although it's a good quality to not do things sloppily when it's possible to do that, right? So, I don't have that instinct. I just do everything sloppily. And you have an advantage over me if you really feel compelled to do things very easily. If it's an absolute compulsion that's going to drive you nuts if you don't drive yourself nuts. It takes the time. Okay? But if you can possibly bring yourself to learn to do this really quickly and as nicely as you can, quickly. I mean, it's not too bad. It's not going to be good for precise work. Okay? So my point is, there we have it. Now we said the interval 1/2, 2. What's the interval 1/2, 2? So the interval 1/2, 2. This is what we might try. Let me make it ring. Okay, there's 1/2. And there's 2. So here's the interval 1/2, 2. These are closed brackets. So these points are supposed to be filled in. Okay. And the corresponding points on my graph. What are the corresponding points on my graph? This point here is above this one, right? And this point here is above this one. And of course, this line is x equals 1/2, and this line is x equals 2. And really, when you do the graph, you should take the time to label your construction lines, at least the ones that are relevant to the question. Okay? You wouldn't necessarily have to label all the construction lines. You're not going to need this one, this one, or this one. But yeah, you need this one, this one, and you're going to need this one. So probably want to go to that. Like it's 2 line, and now we have everything you need to identify the coordinates. And you don't really need the construction lines to do it, but nobody was doing construction lines last time. And I've still not seen a lot of construction lines. I haven't seen that many graphs. Okay. I haven't seen labels of construction lines. That's important. You have to do that. Okay. I think you stressed that last time. Okay. So all that digression aside, it looks like we got the points. One half, 1/4, and 2/4. Okay. Now, how much does x change between those 2 points? Well, let's talk about what a change means. If you go from milepost 11 to milepost 19, you had a change in your coordinate along the interstate, didn't you? And how much change was that from milepost 11 to milepost 19? Hold on, fingers. Yeah, okay. Okay. Yeah, I think most of you see it. Maybe you weren't listening, maybe you're thinking about something else. I used to do that all the time, so don't feel bad about it. Try to focus if you can. Okay. Now, yeah, I'd lose a lecture 10 minutes into the lecture because I'd start thinking about something and then I'd miss something and then I didn't understand another word for the next 50 minutes. But it's still good for me to be there. Something I did better when I attended the lectures than I did. But I usually had to dig it out of a book or something else. Okay, so we didn't have internet when they closed the internet back in those days. Okay, so that's the point. What if you went from mile 15 to mile 9? What would the change be? Negative 6, actually. Yeah, it's negative, and it's about that. Okay, it's a negative change. Okay, so how do you get the change of something? You subtract where you are from where you're going to be. Okay, or where you were from where you are. Okay, You subtract the earlier from the later. So the change from this point to this point, okay, how much does X change and how much does Y change? Well, I don't have time to break it out because something else I'm going to talk about. I hope you can see this. X goes from 1/2 to 2. So the change in X, that's the delta X, is kind of smudged delta. Delta X is 2 minus 1/2. Okay? Yeah, of course, that's 3/2. I prefer you work in fractions because the experience is going to be good for you later on in this course. But if you want to call it 1.5, okay. It's better for you if you think 3/2. Okay? And do the calculation 3/2. Okay, Y goes from what? One-fourth of 4. The change in Y is 4 minus 1/4. If 4 is 16/4, you subtract 1/4 from 16/4, you get 15/4. All right, now rate of change, and I'll calculate up here, talk about spreading things all over the board. Like you all spread them all over the paper, so I gotta look for them, but that's okay. I want it there, and I don't mind looking at it. I've got to ask, I will. Okay, now, look. What? And I didn't write that because numbers got all jumbled in my head. I got something that didn't make any sense at all. But it equals 5/2, and that reconciles. Okay. You do it with decimals, you know, that'd be 3.75, that'd be 1.5, but much easier to do with fractions and much better for you if you do. You have to use a calculator to do this. Well, go ahead, but try to get over it, okay? So we got 5/2. Now, what's that mean on the graph? Well, let's try. Right there's a triangle. The hypotenuse goes from point to point. You have a rise and a run. Delta Y is your rise, and that's 15/4. Delta X is your run, and that's equal to 3/2. So we got 3/2 here, from here to here. From here to here, we've got 15/4. Now, what's rise divided by run? Rise divided by run equals slope, which is 5/2. I try to do this because I'd like to see some pictures, but we'll emphasize that a little more next time. If you can, in some of your work, imitate what I'm doing. Now, you can't read what's in there as all the other lines, but it's 5 halves. And it's in a box. So it doesn't indicate, if it's not in a box, it indicates how long the line is. If it's in a box, it indicates the slope. Okay? And it's right next to the line. Now, try to dive this stuff as best you can. Well, that's an introduction to rate of change. Your book gives you some good applied examples. I'd like to give you applied examples. We had to spend a lot of time on something else. And just try to get you started on this side, okay? Open math will tell you the rest. If you understand this much, that's what you need to focus on. Everything else goes into this, okay? So that's in a nutshell what you need to know, but there's some details. You're gonna have to look at the videos or read the book or whatever to get some of the details. But if you got this, you got 3/4 of it. Fair enough? Now I gotta go on and talk about composite functions. And it's gonna have to be a little bit, much less than I would prefer. But the essence is this. I haven't talked about composite functions here, have I? Don't think there's any reason I would have, just in case. You don't know what I might have said. Okay, so let's let f of x equal 2 to the x. So let's let g of x equal 1 over x. And what do I mean? If I say f of g of x. Well, we have gone over function notation in here, and you should by now understand. And if you don't understand it, review through my video or through one of my MDE 61 videos where we spend a little more time on it, okay? But what does it mean? It means that x has been replaced by g of x, doesn't it? Would you agree? X has been replaced by g of x. Well, if you replace x over here by g of x, what do you get? Write it down. I'm not going to look at it, but write it down for yourself so you can feel good about your answer or correct it. Okay? It should be obvious. I replace x by g of x. What do I get? Well, what I get is 2 to the g of x. Now, you might have written 2 to the 1 over x. If you did, you skipped a step that you probably shouldn't be skipping just now. But later on, you skip it regularly, okay? By the time you get to calculus, you should understand this composite notation really well, okay? Because there's an important rule that people always screw up that's involved with composite notation because people don't understand what composite is. Understand it now. So when you get to an applied calculus or an engineering calculus course, you'll be ready to understand what's really going on, okay? Without having to stumble over function notation like I had to, because I didn't know when it came into calculus, okay? And my high school was great. They gave me a great course in mathematical logic, which ultimately was more profitable to me than pre-calculus would have been. It was good for my soul to figure out pre-calculus while I was taking a tough calculus. Okay, not everybody could do that. But I know other people could, you know. And I didn't do as well in the course as I could have. Okay, so I know what it is to stumble over stuff you ought to know. And you're always stumbling over stuff you don't know, just when you come into this course, inevitably, because there's stuff you just either didn't get or weren't even taught, okay? Okay, anyhow, 2 to the g of x. Now, what's g of x? It's 1 over x. Now we can give this function a name. You can call it h of x. Perfectly good name. Okay. Now, another function that I'll call k of x. We could do the composite the other way and see if we get the same thing. Now, if we follow the rule, what happens? The rule says g of x is 1 over x. Okay, and we're doing g of f of x. Right? So x has been replaced by f of x. So we replace this x by f of x. So write down what you get. Just a little time to process and write it down. Almost out. Okay. Now, what I would hope you would have written down is 1 over g of x. And that should be obvious if you look at the definition and look at this expression. Now, one thing could be a little confusing is it would be also legal to replace g of x with 1 over x here. Okay. I recommend you start this way, unless the other way just makes it much easier. And don't worry about the other way at this point. Once you understand this, then you'll be able to understand it the other way. Okay? And it doesn't matter which way you do it. So I'm only doing one way, keep it as simple as possible. Well, 1 over g of x is 1 over, sorry, 1 over, I wrote that wrong. If you wrote down 1 over g of x, you really screwed up, like I did. Okay? It's 1 over f of x. This is right in my mouth, I forget what I'm doing. Okay? So you got 1 over f of x, and f of x is 2 to the x. What I was going to write down is this g of x wasn't going to make any sense at all. Okay? So it's 1 over 2 to the 1 over x. Okay? So this is the same as this. Okay? For example, if you let x equal 0, what's 2 to the 1? Well, you can't let x equal 0, can you? Wait a minute. Oh. I'm writing down things that I see. I'm sorry. It's got to be confusing. F of x is 2 to the x. My eye caught that, so that's what I wrote down. Talk about running my mouth. Let's do something. Okay. Okay, I'm sorry. I do apologize, but everybody understand? 2 mistakes that I made in writing out this simple thing. Don't you do that. Okay. Do what I say, don't do what I do. Okay. This is not equal to this. Matter of fact, by the rules for exponents, this is 2 to the negative x. And what's 2 to the negative x mean? It means 1 over 2 to the x. You've applied that rule if you've done the arithmetic for the exponential function. Okay? Now, there's much more to it. Let me just make a quick comment since we're not too far over time. Officially, we're not over time yet. It still says 1:51, but any second now it's going to change. You can plug any number in here, can't you? 2 to the x always has a value. Okay? Because the function goes from, it has an asymptote from the negative x-axis to 0. It never hits 0. It's always positive, and you can always do 2 to the positive number. Okay? This one, x can't be 0, right? So you have a restricted domain here, you don't here. What about the range? Well, I'm going to have to let you think about that because I don't want to keep you here. Not that I mind having you here, you're welcome to stick around, but there it is. That's the foundation of doing composite functions. If you know that, you're at least halfway there on the assignment. Okay? There's more, and you're going to pick it up from open math, okay? And if you don't, I'll see you next time and we'll get it together.